Okay, example 2. Nationally, 60% of PhD students have paid internships. A college dean feels that this is not true in his state. So he randomly selects 50 PhD students and finds that 52% have paid internships. At alpha equal to 0.05, is the dean correct? Okay, so step number 1 are null and alternative hypotheses. We have to be careful which one is referring to the population and which one is referring to the sample. So it says nationally, 60% of PhD students have paid internships. So that's talking about the population. So P equals 0.6 or 60%. The alternative, I look to see if there's any keyword that would indicate a direction. The only thing is that it says a college dean feels that this is not true. So there's no less than, no greater than. He just doesn't think that that 60% is right. So not true is indicating a not equal to case. Remember that if there's no direction indicated, we stick with the not equal to case. Okay, step number 2. Oh, also guys, these numbers should always be the same. We do not change the value for the null and alternative hypothesis. So they should always match. Okay, so looking at the distribution, we have a normal curve. Since we're testing the not equal to case, we need to shade both sides. The alpha in the prompt was 0.05. So if I split that between the two sides, I'd have 0.025 on the right and 0.025 on the left. Looking that 0.025 up on the negative z chart, I'm going to get a critical value of positive or negative 1.96. Again, that's the closest number to 0.025 on the negative z chart. Step number 3, the test statistic. P hat, that's the sample proportion, which was 0.52, minus the hypothesized proportion, 0.6, divided by the square root of P, 0.6, times Q, the complement of 0.6 is 0.4, divided by N, which is 50. All right, guys, I'm going to go over to stat and tests and again select number 5, one prop z-test. That's for one proportion z-test. Our null hypothesis was 0.6. We were not given a number of successes, but what we do know is 52% of the 50. So I'm going to multiply and figure out what is 52% of 50. Okay, so the calculator tells me that that's 26. So just in X always has to be a whole number. It needs to be discrete data. So if you do get a decimal place for that, you would want to use regular rounding rules to round to a whole number. N is 50. So that means that 52% of 50 is 26. So 26 people in my sample had paid internships out of the 50 people that were surveyed. The alternative hypothesis is the not equal to case for this one. So I'm going to highlight the not equal to and then calculate. The test statistic, z equals negative 1.15. And the p-value for the calculator says p equals 0.2482. All right, again, you can make your decision either way here. If I put that negative 1.15 on the graph, that's going to fall in this region. It's the non-shaded region, the non-critical region. Also, I can compare the p-value to the alpha. In this case, P, 0.2482, is bigger than our alpha level of 0.05. So P is greater than alpha. So P is not low. When P is not low, we do not reject the hoe. So we're not rejecting the null hypothesis. That means that we're sticking with the idea that the proportion is 0.6. So is the dean correct? No, the dean is not correct. So at alpha equal to 0.05, there is not sufficient evidence to believe the dean that the proportion of PhD students that have paid internships is different than 60%. In other words, at alpha equal to 0.05, there is sufficient evidence to say that the proportion of PhD students that have paid internships is 60%. All right, guys, I would like you guys to try one. So take a look at this you try example, pause the video here, see if you can go through those 6 steps of hypothesis testing for proportions, and then unpause the video to get the solution. Okay, here's the solution to this last example in our notes. Step number 1, the null and alternative hypothesis, P equals 0.6. And then for the alternative hypothesis, the proportion is greater than. There was more than 60% was the keyword in the prompt. Step number 2, we shade the right tail region on that normal curve. Looking up 0.05 on the negative z-chart, or you could look up 0.95 on the positive z-chart. The closest value is 1.645. So again, 1.64 and 1.65 were evenly split around 0.05's probability. So we average those two z-values together. The test statistic value, 0.69 is what I got when I took 138 divided by 200. So that's the sample proportion, or p hat, is 0.69 minus 0.6 divided by the square root of 0.6 times 0.4 over 200. I went to the calculator, guys, and I used the 1prop z-test function. It told me that the test statistic comes out to 2.598. The p-value is 0.0047. I rounded that. Okay, taking a look at our decisions, if we place the test statistic on the curve, 2.598 is further to the right than that 1.645. Again, zeros in the middle. My critical value line was at 1.645, so 2.58 is further to the right. That is in the rejection region or the critical region. Also, using the p-value, p is less than alpha. The p-value is 0.0047. The alpha value is 0.05. So p is less than alpha. When p is low, we reject the hoe. Okay, so that's the decision to reject the null hypothesis. And the summary statement would say, at alpha equal to 0.05, there is sufficient evidence to say that more than 60% of people are trying to avoid trans fats in their diets. Okay, guys, this concludes notes for today. Let me know if you have any questions.